In this video, you will learn how to use factoring to solve problems. So bottom line, what we are doing is we are working with word problems. So I'll walk you through a couple word problems, and each of them might have a little different approach to the setup. But once you get the setup, you'll need to know how to factor in order to solve the word problem. So example 1, it says the sum of a number and its square is 20. Find the number. So the setup here is not too bad because it tells you pretty much what to do. So we just have to translate this English into math notation. So the word sum means addition. Alright, so we're adding something together. We're adding a number, which we can let be the letter x, and we're adding that with the square, with its square. So we have the number is x, and the square of that number is x squared. And the sum means you're adding them together. So when you find the sum, it says that is going to be 20. So my setup is going to be x plus x squared equals 20, or we many times put the x squared term first. So we have x squared plus x equals 20. Alright, so from here we can solve by factoring. And to do that, we want to set this equal to 0 first. So we can bring the 20 over to the left side. We do that by subtracting. Now we have x squared plus x minus 20 equals 0. So from here, we can factor that left side. And we have x times x to get x squared. And then we need a number, or two numbers, that would multiply to get negative 20. And would add to give me a positive 1. Well, if I had a positive 5 and negative 4, that would multiply to give me negative 20, and then they would add to give me a positive 1. So I can factor this as x plus 5 times x minus 4. Now from here we can solve. Because we have one number multiplied by another number, and that product is 0, we know that either of these two numbers, either x plus 5 or x minus 4, must equal 0. So we can solve this by subtracting 5. We have x equals negative 5. And then over here we can add 4, so x would equal 4. So we have two different solutions. X could equal either negative 5 or x could equal 4. We can double check by plugging these numbers back in. So in place of x, we could put a negative 5 in. We'd have negative 5 squared, which is 25, plus negative 5, which would equal 20. So that works. For the 4, we could plug that in. 4 squared is 16, plus 4, that would equal 20. So therefore, we do have the correct solutions. X is negative 5, or x is equal to 4. For example 2, we are told to find two consecutive negative numbers that have a product of 90. So to begin with, look at this phrase, two consecutive negative numbers. What that means is two negative numbers that come right after the other one. So for example, if you had negative 3, the next number is negative 2. So those would be consecutive negative numbers. Or if you had like negative 10, then negative 9 would be the next number. So those are consecutive. So we don't know what our answer is, but we know that they are consecutive and they're negative. So if we let the first number be the letter x, we know the next number would have to be one more than the first number, right? If we started with negative 3, for example, we have to add 1 to get to the next number. If we started with negative 10, we would add 1 to get to the next number. So whatever that first number is, we need to add 1 to that to get that second number. Now it says the product is 90. Product means multiplication. So if I multiply x times x plus 1, that will equal 90. So this is my equation, and from here I need to solve. So I can begin by distributing x times x and x times 1 to get x squared plus 1x. And then I need to set this equal to 0. And I can do that by subtracting 90 from both sides. On the right side, 90 minus 90 will cancel. On the left, I have x squared plus x minus 90. Now from here, I can factor this left side. So to factor, we would have x times x to give me x squared. And then I need two numbers that multiply to get negative 90 and would add to give me a positive 1. Well, that's going to be a positive 10 and a negative 9. That would multiply to get negative 90, and they would add to give me a 1. So that is how I factor that left side. And now, since everything is being multiplied, we have x plus 10 being multiplied with x minus 9, I can set each part equal to 0. So either x plus 10 is 0, or x minus 9 is 0. And then to solve, I can subtract 10 from both sides. So here we have x equals negative 10. And then here we can add 9, so that x equals 9. So x equals negative 10, or x would equal 9. Now take note that there's really only one correct answer, because looking back at the initial question, we were told to find two consecutive negative numbers. So that means we'd be using this negative 10 here. So 9 is not an answer because of the directions. So the first number is negative 10, which means the number after that is one more than negative 10, which would be negative 9. And we can double check, because when I multiply negative 10 times negative 9, we do get positive 90 back out. Example 3 is similar to example 2. We are told to find two consecutive positive odd numbers that have a product of 35. Now this one is probably easy enough to do in your head, and you can probably figure out it'd be 5 times 7, but it's important to get the process down in case we have more difficult type of questions. So here it says two consecutive positive odd numbers. So that'd be something like, 9 and 11, or maybe 19 and 21, or 23 and 25, or whatever. Two numbers that are odd, where we have the two that are right one after another. All right, so that would be our definition of consecutive and odd, something like this. But we don't know what it is, so if we let the first number be x, so if the first number is x, then the next number is 2 more than that, right? 9 plus 2 is 11, 19 plus 2 is 21, 23 plus 2 is 25. Whatever the first number is, we just add 2 to find the next odd number. So the second number is x plus 2. And then it says the product is 35, which means when I multiply them together, that would equal 35. So x times x plus 2 equals 35. Now I can solve this. We have x can be distributed, so that would give me x squared plus 2x. I need to set this equal to 0, so subtract 35 from both sides. So on the right side, that would be 0. On the left side, we have x squared plus 2x minus 35. That left side can factor. So to get x squared, we would have x times x. And then we need two numbers that multiply to get negative 35 and would add to give me a 2. And that would be a positive 7 and a negative 5. That would multiply to get negative 35, and 7 plus negative 5 would give me 2 for the middle term. So that is how I factor this left side. Now that everything's being multiplied together, I can set each part equal to 0. So either x plus 7 equals 0, or x minus 5 is 0. So when I solve this, we subtract 7 from both sides. X would equal negative 7, or x would equal 5. All right, so we have our solution, but look back at the initial question. It says that it must be positive, which means negative 7 would not work. 5 would be my solution. So the first number is 5, and then the second number is 2 more than that, which would equal 7. So 5 plus 2 is 7. So my numbers are 5 and 7. And we can double check because 5 times 7 would be 35. Example 4. This one is more difficult. It says you are designing a poster that has a rectangular print with a uniform border. The print is to be 3 times as tall as it is wide, and the border is to be 4 inches wide. If the area of the poster is to be 112 square inches, find the dimensions of the print. Now it's helpful to draw yourself a picture. Alright, so here's our picture. This innermost rectangle is our print. Okay, that is our picture. And then the border would be this outside part. Okay? Uniform just means the same length. So that means that this distance is the same as this distance, and that's the same as this, and that is the same as that. Alright, that's what uniform means. So that part is your border, and then the inside is your print. Now with this picture, we need to start labeling different things. So it says the print is to be 3 times as tall as it is wide. So whatever the width is of this print, this innermost rectangle, the length, or I guess the height, is going to be 3 times that. So if this right here is your width, that's W, then your height is 3 times that, or 3W. And then it says the border is to be 4 inches wide. So the border means right here would all be 4 inches. Alright? So it then says the area of the poster is to be 112 square inches. The poster would be everything together. So if I take, this entire length down here, then multiply it by this entire height right here, that's going to give me my area, which is 112 square inches. So we need to figure out what is this length and what is the height of this entire thing. Alright, so looking at the print. So the print width is W. If I add this length of 4 with W, and then this other length of 4, that's going to give me the entire thing down here. So I take the width, add 4, and another 4, which would be the same as adding 8, and that would be the bottom. So the bottom is the width plus the 4 plus the 4, which would be the width plus 8. And then same concept for this height. This height right here of the entire poster is we have this 3W, but then we have to add 4 and another 4, which is adding 8. So I add 8 to 3W to get 3W plus 8. And then it said the area is 112 square inches. So the area of a rectangle is length times width, or base times height, or whatever way you want to think of that. We take the bottom, the W plus 8, and multiply it by 3W plus 8. So W plus 8, and then 3W plus 8. And that area is 112. So that is my equation. So we have 3W plus 8 times W plus 8 equals 112. So from here, we just need to solve. And to solve, I need to bring the 112 over to the left side, and I need to then distribute the 3W and the 8 to both terms for the W plus 8, and then combine the 112 with that. So let's get started. We have 3W times W and 3W times 8. That's going to give me 3W squared plus 24W. And then distribute the 8. We have 8W plus 8 times 8, which would be 64. So we have 8W plus 64. That's equal to 112. All right, so then from here we can combine the 24W plus 8W. That would give me 32W. So 32W plus 64 equals 112. And then we want the 112 over on the left side. We do that by subtracting 112. So that gives me a 0 on the right side. And then on the left side, we have 3w squared plus 32w. Then 64 minus 112. That would give me, what, negative 48. So we have 3w squared plus 32w minus 48 equals 0. And we see that typed up a little neater right here. So from here we can factor. So that left side, we would have 3w times w to get 3w squared. And then we need to get negative 48 for this last term. We get that by multiplying two numbers together. So this will take some trial and error. You could do 1 times 48, 2 times 24, 3 times 16, 4 times 12, or 6 times 8. And with some experimentation, we would find that if we put a negative 4 and a positive 12, that would multiply to get negative 48, and that would also give me the middle term of 32, because we have negative 4w, then 3w times 12 is 36w, which would add to get 32w. So that is how I factor the left side. And then from here, I can solve because this is one number multiplied by another number. So I can set each part equal to 0. So we have 3w minus 4 equals 0, or w plus 12 equals 0. So for the first one, we can add 4 to both sides. We have 3w equals 4, and then divide by 3, we have w equals 4 over 3. So the width is 4 over 3, or I can subtract 12, w equals negative 12. Now, a negative width does not make sense, right? We cannot have such a thing as a negative width. So this negative 12 does not work, which means my width must be 4 over 3. So that is what I see right here. The width is 4 over 3 inches. All right, so that would be this part right here, 4 over 3. And then we want the height as well. So 3 times the width, or 3 times w, means I would have 3 times 4 over 3, which is the same thing as 3 over 1 times 4 over 3. The 3's can divide out. That leaves me with 1 times 4, which would be 4 for the height. So the width is 4/3 of an inch, and the height would be 4 inches. One more example, and here we have a physics application. For this problem, it says when an object is projected into the air, use the formula h equals r times t minus 16t squared to approximate the height h in feet of the object t seconds after it is projected upward with an initial speed of r feet per second. So the h is the height of the object, t is the number of seconds after the object was thrown or projected, and then r is the initial speed that we threw or projected that item. And so given that information, we are told that an arrow is shot at 96 feet per second. And the question is, when will it reach a height of 128 feet? So the height is 128 feet. So that is my h. And then 96 feet per second, that is my rate, or the initial speed of the arrow. And then t is the number of seconds after the arrow is shot, which is what we're trying to solve for. We're trying to solve for t. So what I do is I plug these numbers into the equation. And it's color-coded to help make it a little bit easier, hopefully, to see what is happening. So we plug the 128 in for h, 96 in for r, and then solve for t. So when you do that, you now have 128 equals 96t minus 16t squared. So what I need to do is solve this by setting this equation equal to 0 first. So to do that, I like this t squared term to be positive. So let's bring this to the left side and 96t to the left side. So we can do that by adding 16t squared and subtracting 96t from both sides. On the right side, this will all cancel. That gives me 0. On the left side, I will have the 16t squared, then the minus 96t, and then a positive 128. So that's all equal to 0. So I just moved everything to the left side by subtracting the 96t, then adding the 16t squared. So here's my equation, and I now need to solve this. Well, to solve, I can begin by factoring out a greatest common factor. So looking at the 16, 96, and 128, I can find the greatest common factor, and if I do that correctly, I will find that that would be a 16. So I factor a 16 out, and I'm left with t squared minus 6t plus 8 in parentheses. And then in the parentheses, I can factor that further. If I factor that correctly, I'm going to get t minus 4 times t minus 2. Because negative 4 times negative 2 is a positive 8, and negative 4 plus negative 2 would give me negative 6 for the middle term. Now from here, everything is already multiplied together, and it's all equal to 0, so I can solve by setting each part equal to 0. So 16 could equal 0, which doesn't make sense, so we can ignore the 16. We have t minus 4 equals 0, or t minus 2 equals 0. So if that's the case, then t would equal 4, or t would equal 2. So my solution is that the arrow will reach a height of 128 feet after 2 seconds and after 4 seconds, which would make sense, right? If you shoot an arrow up into the air, it's going to go something like this. So let's say 128 is right here at this point. So on its way up, after 2 seconds, it's going to reach 128 feet, and on the way back down, after 4 seconds, it's going to be back at the same height at 128 feet. So my solution is 2 and 4 seconds. And that concludes our lesson for today. We will see you next time.